Hi everyone and welcome to this, my video on the Northern Hemisphere 2024 Paper 1 General Mathematics exam. My name's Darren from Maths Guru. Thank you very much for joining me. Hopefully you're going to find this video useful. If you haven't already, skip past it. Before I go any further, can you do me a massive favor? Can you subscribe to my YouTube channel and like this video? It really does mean the world to me when people subscribe and like. If you need to, turn the notifications off, but so few people watch maths videos. If you've actually watched this and found it useful, click that like button, click the subscribe button. It'll be great. At the moment, I'm at 11,000 subscribers. My God, I'm powering towards viral, not so much. Now, obviously, these are going to be my suggested solutions. I do not have any link to the VCAA or to the Northern Hemisphere writers, or I don't correct this. So basically, these are just my suggested solutions, hoping to help you out. Now, if I do make a mistake, and that's highly likely, well, hopefully not, I'll put it in a errata below or on maffsguru.com. As you can see, this was a 1 hour and 30-minute exam with 15 minutes reading time, and there's lots of hints and tips I can give you about reading time, but you're probably not interested in that at this moment in time. So there we go. We've got a histogram below, shows the distribution of the GDP per capita, gross domestic product, in dollars per year for a sample of 41 African countries. There we go. And the median GDP per capita in dollars per year for this sample will be within the range. Now, obviously, it'd be great here if I could reduce this, but I can't. So what have we got here? The median, that's the middle. Well, first things first, did it tell me how many there were? There were 41 African countries. So if I want the median, I'll do 41 plus 1 divided by 2, which is going to give me my 21st data item. And again, hopefully you understand here that means take the number of data items, add 1 and divide by 2. That will give you the position of the data item you want. So I want the 21st data item, not that it's 21. Now what do I do now? I'll go that's 2, and I go there's 11, and I go that there is 12. And what I'm basically doing is trying to work out where the 21st is going to be. So that's 2 and 11 is 13. So up until here is 13 data items. 13 and 12 gives me 25. So I reckon my 21st is going to be somewhere between 2,000 and 3,000. Let me get greater than or equal to 2,000, but less than 3,000. So in this situation, I'm going to say that C is my correct answer. Moving on to question number 2, the variables exercise type, aerobic, boxing, and circuit, and recovery time, short, medium, long, are what? Exercise type, well, that's categorical. So again, what I tend to type over here is categorical. And recovery time, short, medium, or long, is also categorical. And so hopefully we're going to say here both. Oh, hold on a moment. Now, categorical, but in this situation that they are nominal. And what you'll notice is there, I didn't get any just categoricals. It wants to go that little bit further. So nominal means that there's no implied order. And if I look here, there is no way I can put an order to aerobic, boxing, or circuit. What about this one? Short, medium, or long? Well, in that situation, that is actually ordinal because there's an implied order. If I put those 3 cards around the house, my 5-year-old daughter, I'm fairly sure if I told her to put them in an order, would go short, medium, long, or maybe long, medium, short. But either way, the English language lets us believe that has an implied order. So what have we got? I've got nominal and ordinal. So a nominal and an ordinal respectively. I'm going to put B there as my correct answer. Okay, so moving on to question 3, the dot plot below displays the number of errors made in a test for a sample of 15 students. The mean and standard deviation for the number of errors are closest to. Now, actually, in this situation, I can't work that out without bringing up my calculator, and I appreciate at the moment my calculator is going to cover some of that data, and I also appreciate that this isn't a ClassPad. Guys, if you're a ClassPad user, on the whole, the functionality is pretty similar. Hopefully, you will find the way to do it on your calculator. If I added those instructions to these videos as well, it would blow the time out somewhat massively. So what I'm going to do is I'm going to go menu, and what I want to do, a list and spreadsheet. Yep. And here I'm going to do basically num. And you got to be careful what you choose here for your num of errors. So go 3, 3, 4, 5, 6, 7, 8, 8, 8, 9. All I'm doing is putting the data items in. I've got 4 10s. I know you can't see that at the moment, but you will when I get rid of it. And there we go. Now, obviously, in this situation, what I tend to do is it says I've got 15 students. I want to make sure that I've got 15 data items. I do a quick scan up to make sure that there are no problems there, that I haven't done anything stupid. And now I'm going to go menu, statistics, stat calculations, sorry, I did that way too quickly. So menu, statistics, stat calculations, and I want one variable statistics. Okie dokie. What is my X list? Well, we've got to tell it that basically we've chosen it as num because your calculator is literally a dumb piece of machinery. Click on OK, and there we go. So what have we got here? So I've got my, oh, shucks, what on earth is that value? Well, if you look down the bottom here, we've got it as a decimal, but it would suggest my calculator's in the wrong mode. That's going to be annoying. So we've got here, my one variable statistics is 7.4666, so 7.47 for my mean. So let's highlight anything that's got 7.47 for my mean. And my standard deviation is that SX1, which again, if we look at the value down here, is 2.69 or 2.70. So if we highlight that one for 2.70, we're going to end up with E as my correct answer. So that was a calculator enabled. Now, what I'm going to do here is hit my calculator and actually put it into a slightly, oh my goodness, I'm going to put it into a slightly more useful mode. Document settings, and put that into approximate. And again, for those of you who are using the TI Inspire, always make sure you put this in float, not float 6. We've known it before that you get lots of silly answers, or it rounds in really strange places. So there we go, now we've got it in decimals. Right, turn that off, we don't need that anymore. And let's move on to our next question. The histogram below shows the distribution of the GDP per capita in dollars per year for a sample of 22 countries in 2021 plotted on a log base 10 scale. Now again, when I teach my guys this, I'm like, hold on a moment, it's a log scale. Before we go any further, we're going to turn all of those numbers into actual real numbers. But of course, thank you VCAA. What have you done now? Well, you've tried to throw a spanner in the works. Because actually, normally we'd have things like 3, 4, 5, 6, 7, 8, but they haven't done that. They've done 3.6, 3.8, 4. Oh. Well, we do know that the ones that are whole number numbers, I can now write that with the 1 and 4 zeros. That's going to be a 1 and 5 zeros. 1, 2, 3, 4, and 5 zeros. And let's see what the question actually says. Australia is one of these 22 countries, and its GDP per capita value is 56281. Which one of the columns marked A, B, C, D, or E would contain Australia's value? Oh, well, actually, as it turns out here, what they're asking me to do then is to work out the log of 56281. Oh, great. Well, let's fire up my calculator. Let's put in a new, insert a calculator, and I'm going to go control log base 10 of 56281. Hit enter, and we get 4.75. Now, where is 4.75 going to be? 4.75 is going to be somewhere between 4.6 and 4.8. And so I'm going to choose C as my correct answer. And it always fascinates me with VCAA that they find so many different ways of asking questions. It just blows my mind. And there's not a lot left of that because I'm 127 years age. Now, if you can subscribe to my YouTube channel, please do like this video and spread the word. Head over to maffsguru.com where all these videos are there. There's so much content for you if you're already starting year 12. But now I'm babbling. The height of a group of year 9 students were measured and the standard deviation was found to be 12.25. One student with a height of 174.6 had a standardized score of 0.45. He says trying really hard to turn the page and messing it up. All right, what does it say here? The mean height of the group of students in centimeters was closest to. Oh, hold on a moment. We know that a z-score is given by x bar minus mu. I'll try that one again. Is x minus x bar on mu, all right? And if we remember, that's the actual data value is equal to the mean divided by the standard deviation. So can we substitute some values in here? Well, we know the z-score is 0.45. We're trying to find the mean. We know his actual height was 174.6. We're trying to find the mean, and I have my standard deviation of 12.25. Now, again, you don't have to do this the hard way. What I'm actually going to do is just move this over a bit here so that once again I can fire up my calculator. And what have we got here? I can now solve. So menu 3, 1. And we're going to do 0.45 equals. And I'm going to do control and divide. He says, I hit the wrong button. Nope, let's go back down to here. Oh. Trying to do this on a computer is actually really quite challenging. 174 0.6 minus, I'm going to call it x because it doesn't really matter what I call it, 12.25, and then we're going to comma x and hit enter, and then we get 169.1, which I think is therefore going to give me B as my correct answer. Oh, I'm loving this so far. All right, remember to turn off the CAS. All right, what do we got here? The weight of cans of fish on a production line are approximately normally distributed with a mean of 126 gram and a standard deviation of 2.4 grams. All right, 13,600 cans of fish will be produced today. Useful. Using the 68.95, 99.7 rule, the number of these cans that are expected to weigh between that and that is right. Okay, so the first thing I do is I draw my nice standard deviation. And because I can use color, I'm going to split that up into my little sections. So those are my 3 sections. So what does it say? The weight of cans are normally distributed with a mean. So I now know the mean is 126.4 and the standard deviation is 2.4. So each of those gaps is 2.4. Now again, I don't like making mistakes. I try really, really hard not to make mistakes. So what I tend to do now is this. I'm going to go 126.4. 126.4, hit enter, and I'm going to do plus because it's going to take my previous answer, and I'm going to add on 2.4. When I hit enter, I get 128.8. Hit enter again, I get 131.2, and hit enter again, I get 133.6. Now that's helpful. What am I going to do now? I'm going to go up and copy 126.4, and now I'm going to hit enter, and I'm going to do minus. And I'm going to do 2.4, and I'm going to do it once, which gives me 124. And do it again, which gives me 121.6. And do it again, which gives me 119.2. Now, again, you're going to turn around and say, well, surely you can do that in your head. I could, but if I make a stupid mistake, then that's not particularly helpful. Right, what do we want? We want between 121.6, which is here, and 128.8. which is here. So we're basically looking for the areas of this section here. Now, obviously, firing up the sections that we need, I know that this section here is 34, and that section there is 34, and this section here is 16.5. And then when we basically add those together, we're going to get 34 and 34 and 16.5. Add those together, it's going to give me 81.5%. Is that, oh no, hold on, that's not what they're asking for. No, because they want to know the number of cans. So I want to try and work out 81.5% of 13,600. Now, I'm not going to put that into my calculator. I've already worked that out to be 11,084. And so as far as I'm concerned, D is going to be the correct answer for that. Data was collected to investigate the association between 2 variables, age in years, uses public transport, yes or no. Which one of the following is the appropriate way to display this data? Okay, now, age in years is numerical, and uses public transport is categorical. Now, if you are using the Cambridge textbooks for VCE, one of the end of the chapters, which graph actually tells you the best one to use for numerical and categorical is actually parallel box plots. So that's just grabbing your summary book and having a look and saying, well, which one is the best one for numerical? And 2 categories, it is parallel box plots. A class investigation considers 20 countries and any association between the birth rate per 1,000 people and the life expectancy in years. Students were given the following table of summary statistics. Now, again, when I see this, I absolutely love it. It comes down to that one tiny little bit somewhere in the textbook that tells you how to relate the mean and the standard deviation for a birth rate and a life expectancy. All right. And there are those 2 formulas there, including the idea that I think it's B is equal to R SY on SX, and Y is equal to A bar minus B X bar, or something along those lines. I can't remember them off the top of my head. But the question goes on, and having given you that information, says scatter plots A, B, C, D, and E show attempts by 5 students to fit the calculated least squares line to a scatter plot of the original data. Well, hold on a moment. We don't have the least squares line. We've got the information, but how are we then going to work this out? Well, exactly that. So I went away and I got my formulas, and I found out that my slope was given by minus 0.752 times, that's R times the standard deviation of the birth rate, 4.7, divided by 1.64. Now, again, these are just formulas that we have taken out of our summary books, and that gives me minus 2.155. Having got my slope, my intercept is given by 31.5, which is this value here, plus 2.155. Okay, now the reason it's a plus is because it's a minus and the minus there, so we won't get rid of that. And we're going to times that by 61.7, which again gives me 164.5. Now you're going to turn around and say, well, how is that going to help us? Well, scrolling for a moment down here, just because we've got some room, I now know that my equation of my least squares line becomes birth rates is equal to 164.5 minus 2.155 times my life expectancy. Okie dokie. And what I did then was basically work through and say, well, all right, so if I put in 59 into this equation, you're going to say, where did I get 59 from? So if I put 59 into this equation, what comes out? Well, as it turns out, if I put 59 into here, he says, comma, out comes 37.3 and a lot more decimal points. Where do each of my graphs finish? And this is always the best way to do this for lines of best fit or regression lines is 65. If I put that into my equation, I get 24.40. And ultimately now I'm just looking for the graph that when it has 59 is at 37.3 and 65 is around 24.4. And again, if you have the paper in front of you, and hopefully you do, you'll be able to find out that A is actually going to be your correct answer, because that's the one that basically is the closest there, right? Fascinating question. Never seen that type before, but again, awesome. All right, we're moving on to 9 and 10. The scatter plot below shows the average annual income in dollars plotted against life expectancy in years for 42 countries in 2022. The least squares line has been fitted to the scatter plot and the coefficient of determination. Now, again, that's important. R squared is equal to 0.306. Lots of people don't know what it means by coefficient of determination. That's your value of R squared. Right. The equation of the least squares line is closest to. Now, I didn't like this question when I first did it, and I'll be honest with you because I got it wrong. And I was like, well, this is really, really silly. How on earth could I possibly get this wrong? Because what I normally tell people to do is, well, you know, you estimate this value here and you estimate this value here and you put it into your calculator and Bob's your uncle. But as it turns out, that wasn't very accurate. And maybe VCAA have decided that they're going to try and trip me up. So what I actually have worked out you need to do is find out where it crosses the crosses a sort of pair of grid lines. And as it turns out, there is an exact value that we can use. And there's another one as well. This one here, there we go. So those are the two values actually we now can use. And so as coordinates, they were 66, 5,000 and 74, 8,000. Now, again, I'm just going to squish this stuff over here so that when my calculator lines up, it's not going to get in the way of anything. Because you're going to tell me, so, well, how can I use my calculator? Well, believe it or not, your calculator can find least square lines from two coordinates. Yeah, it's one of the best things we can actually use it for. Now, what I'm actually going to do here is I'm going to go doc, insert, problem. And you'll notice that I actually can, what I'm going to do a list in the spreadsheet. And you'll notice the numbers on the top here change from 1.1, 1.2 to 2. And anything now I put into here won't impact those other tabs. Very, very useful thing to know. So what am I going to do here? So I'm going to do life expectancy and, oh, no, you muppet. Not you, of course, me. Let's go back up here. Life expectancy and what I got? Income. He says, not being able to type. Right. So my life expectancy is 66. My income is 5,000, and then go down to here and we go 74, 8123, right? And then I'm going to go insert a data and statistics, click on here. What have I got here? Life expectancy. What have I got here? I've got inc, not an E. All right. And if I go menu, analyze, regression, and linear A plus BX, there we go. What do we get? Minus 19750 plus 375. Now, again, when I did this and I tried to estimate it from that point there and that point there, because those points can't be accurate, I actually got E, and that would have been a tragic, tragic waste of a mark, really. Which of the following statements is true? The value of the correlation coefficient is 0.306. Well, no, because they basically told you the value of the correlation. If we go back, It said here the coefficient of determination is 3.06. So that's a no, he says. Let's cross that through. There are more data points above the least squares line than below. Well, if we look at the least squares line, you can actually count them, and it turns out even by inspection that certainly isn't true. 30.6% of the variation in annual income is not explained by the variation of life expectancy. Well, basically, no, because it's 30.6% is explained. So that's no. The country with the longest life expectancy has a positive residual associated with it. Well, the longest life expectancy is this one here. That's below the line, which means that that value there would be a negative residual. And so by a process of elimination, it's got to be E. Using the least squares line to predict the annual income of a country whose citizens have a life expectancy of 54 years is an example of extrapolation. Yes, why is it extrapolation? Because 54 years falls outside the data set by which our least squares line was created. Sheesh, that took a long time to talk about. Where are we now? Use the following information to answer questions 11 and 12. The table below shows the birth rate in number of births per 1,000 people and the average annual income in dollars per person for a sample of 12 countries. A scatter plot displaying the data is also shown. That's very definitely curved, isn't it? I got a funny feeling where this is going. A square transformation applies to birth rate. All right, so what I'm going to do now is I'm going to highlight that because a highlighter makes life so much easier. Can be used to linearize the scatter plot. The equation of the least squares line is, thank you. Using this equation, the predicted birth rate in number of births per 1,000 people for a country with an average annual income of that is closest to. Well, okay, in which case, it's just a calculator question. So I'm going to fire up another calculator, put it in this one. Have I already got a calculator in here? No. So let's do that one here. So now I'm going to go menu, 3, 1. I'm going to solve, and I'm going to say, let's do this as y squared, because it's my birth rate squared, is equal to 953 minus 0.0333 times, did they give me my income? Yep, 18500, comma, x, hit enter, and out comes those two values. Now again, do you understand why they've given you two values? Well, because when you square root something, you're actually going to end up with two values. And so that's not necessarily going to be particularly helpful. We want the positive one, and it wants it rounded or closest to 18.4, which is going to give me C as my correct answer. Oh, I thought they were going to ask me to do something really complicated there. Oh no. The coefficient of determination were calculated for birth rate versus income, birth rate squared versus income. Oh, now we've got the coefficient of determination for that, and birth rate versus income squared. These coefficients were ranked in order from largest to smallest. The order would be, Right, okie dokie. Well, actually, I thought we were going to get away with this, but actually we're not. To be able to do this question, we've got to put the data into my calculator. I'm actually going to overwrite this information here and do birth rate, and I'm going to do income, and I'm going to put that data in. Now, obviously, I'm just going to fuzz our way to me actually having already entered the data in. Okay, so there we go. That's all my data in, and then again, I do a quick shift up to make sure that none of those stand out as incorrect. Now, if you can imagine for this question here, we're getting towards the end of the section, and life gets more complicated because they make the questions longer. And if you haven't already subscribed to my YouTube channel, if you could, that would be massive, all right? Turn off notifications, like the video would be massive, because I would really like the people out there to know that the stuff I'm producing is good and helpful. And obviously spread the word. Maths Guru, honestly, no one watches maths videos. If you can spread the word, that would be amazing. Right, so let's go back. We've now got my information in there, and we basically, yes, by brute force, have got to try and work this out. Okay, so what I'm now going to do is it says birth rate versus income. So I'm going to go and do my graph here, and I'm going to go birth rate versus income. Now, as you can see here, it's got my value of r squared, and it says it's going to be 0.7894. So what I'm going to do is write that down there, 7895 to 4 decimal places. It really doesn't matter. Let's go back to that. Now, what I want is to be able to then do birth rate squared versus income. All right, so what I'm going to do here is BR SQ, so that I can call it something useful, BR SQ equals, and then I want var, because you've got to make sure you use that var. So birth rate, and then hit the squared button, hit enter. Let's go back here. and we now want birth rate squared, which lovely gives me 0.8301. So 0.8301. And again, we're now going to go back here. I'm going to change that back to birth rate, actually, so that I don't make a mistake. Here I'm going to do inc square equals var inc squared. Hit enter. Go back to my graph here, and now do inc square, and I get 0.9109. And there we go. So these coefficients ranked in order from largest to smallest would be 3, 2, and 1. And so E would be my correct answer. I can't think of a quicker way of doing that. If you know of a quicker way, that would be awesome. The following graph, it shows the winning time in seconds for each year from 2004 to 2016 for a men's 1500 track event. Awesome. Idea of exercise? No. The time series is smooth using 9 median smoothing. Oh, sheesh. The smooth value for the winning time in 2009 in seconds is going to be, so 2009, we basically want, so let's do my highlighter. 2009 is that one there, and it said it's doing 9 median smoothing. So I want 4 on the left, 1, 2, 3, 4 on the left, 1, 2, 3, 4 on the right. That's because I want 9 dots highlighted with the 2009 in the middle. So that means 4 on one side, 4 on another. Now remember, when you median smooth, we already know that it's going to be centered around 2009. So we already know that it's got to be somewhere on that line. He says drawing a nice line. And what I now need to do is drag my sort of ruler up and sort of go, well, where are the lowest points? And I'm trying to find the 5th one up, because of 9 data items, the 5th one is in the middle. So we got, what do we got here? So we now want to find, so now we want to find the 5th highest dot from the bottom. And obviously this is my first, second, third, fourth, and there we go, 5th. That's my 5th highest dot. So if I was to draw a line from there across, then actually this is where I would do my cross, but I'm looking at the actual data value, which is 209.2, 209.4, and so in that situation, C would be my correct answer. Again, we're only looking to median smooth for those 9 dots, and we're trying to find, because we got the 5th one horizontally, we want the 5th one vertically as well. Right, the number of fruit drinks sold by a fast food shop every day for 14 consecutive days was recorded. The results are shown in the table below. The 6 mean smooth value for centering for day 6 is. And again, if you've done a lot of these past papers, you'll notice a lot of the questions get relatively formulaic. So what do we want? We want the 6th mean smooth for day 8. Well, there is my day 8. Because we want an even number, it means I've now got a smooth on the left of that point, on the right of that point, and then we average those 2 values. Okay, so if we do the left of the point first and highlight the values we're looking at, we want those 3 and those 3, because we want 6. Let's fire up my calculator and go back to here, because I can do that now. So I'm going to go Control and divide, and I'm going to do 129 plus 187 plus 179 plus 71 plus 89 plus 131. Divide that by 6, and that's going to give me 131. So again, I write, not in highlighter, I don't. I write 131 below there. I'm going to rub those out because those are the points I've already done. I'm now going to do the smoothing on this side. Notice that what I do is very visual. It has to be, otherwise I'm going to make a silly mistake. So again, I want 3 on that side of the line and 3 on that side of the line. Now, going back to my calculator, what I can actually do is go up and copy those down. I'm going to add on 147 to the end because the same data items are there. And I'm going to get rid of 129 there. Hit enter, and what do I get? I get 134. So those are either side of the 8. Add them together and divide by 2. And what do we get? We get 131 plus 134. I'm going to divide that by 2. It gives me 132.5, giving me B as my correct answer. All right, the sales revenue in dollars from the sale of chocolate eggs is seasonal. To correct the sales revenue it made for seasonality. Again, when I see correct for seasonality, I know that there's one formula and one formula. Now, if you have signed up to Maffs Guru, you've probably got the downloadable summary book if you've paid that little bit for the downloadable summary book for general maths. And in there will be this formula. And it's probably one of the most important formulas ever. It's 1 divided by the seasonal index to get you minus 1. and I'm going to times that by 100. Ah, it's decreased by 70%. Or again, I get so many tricked. I get so used to the ideas that they've done this. But now, rather than doing what we normally do, because normally they'd give us the seasonal index and ask for the answer, they've actually given us the answer. It's decreased by 17%. Ah, so tricky. All I need to do now is put that in solve and comma for my seasonal index. And let's see what happens. Right, I'm actually just going to move that over so it doesn't get covered by my calculator, he says, not taking the bracket with it. Come on, we can do this. Let's bring up my calculator and see what happens. There we go. So I'm going to go menu 3-1. And I'm going to say in brackets 1 divided by, call it S for the moment. I mean, we call it SI actually. Minus 1 times 100 equals negative 17, comma, SI, hit enter, and SI comes out as 1.204, which is going to be D, as it's closest to 1.20. Okay, again, really clever how VCAA come up with so many different ways of doing it. The seasonal indices for a visitor numbers to a theme park in a particular year are given in the table below. The seasonal index for summer is not given. In this particular year, 33120 visitors attended during summer. The total annual attendance for this particular year is closest to, right. We know from, again, rearranging one of the formulas that the average is given by 33120 divided by the seasonal index. Oh, how are we going to find that seasonal index? Well, what do we know? Well, we've got 4 different values here. And we know that all of those values must add to give me 4. So if I was to do 0.85 plus 0.96 plus 0.45 and take those away from 4, what I actually get is 1.74. Right, so there are my seasonal indices. I'm just going to actually check that. 4 minus 0.85 minus 0.96 minus 0.45 gives me 1.74, and there we go. And now our average is given by the actual divided by our seasonal index of 1.74, which again, when I put that into my calculator, gives me 19034.48. And then I was like, hold on a moment, that's weird. I don't fully understand that. The total annual attendance for this particular year is, that's my average attendance. All I need to do there is then multiply that by each of the 4 months, right? Because again, our average is taken by the 4 months divided. It's sort of very clever again. And when I do that, I get 76137.9, which gives me our closest value as D. Gosh, so clever. And there we go. We've actually finished our data section. Welcome to recursion and financial modeling. If you are new to this section and could do me a massive favor and subscribing to my YouTube channel and liking this video, it will blow me out of the window. All right, subscribe, turn off notifications if you never want to hear from me again. It just shows me that you've watched this video. So few people watch maths videos, and I sit in this room and I talk to myself, and I swear to you, I'm going slowly mad, and it's all very on display. So if you can do that, that'd be great. Now, financial and recursion modeling. I love this stuff, right? It normally starts quite easy. So let's see where we go. Mel bought a new car for 60,000. She would appreciate the value of the car using the reducing balance method, a accounts relationship that models the year-to-year value of a car, M to M. And again, what's important here is the year-to-year. So M0, initial value, obviously reducing balance because we've got some sort of multiplier there. An equivalent rule to determine the value of the car after N years is, and again, we love the fact that we can go from that relatively simply in the summary book. Again, if you've signed up to Maths Guru and you've paid a little bit, you can download a pre-made summary book for general maths, and this type of stuff is all in there. So I know then that M of N would have to be 0.85 to the power of N times M0. Now we know what M0 is because they've told me that. It's 60,123. Now, does that fit anything here? Well, of course, they're going to try and flip it around, but actually, as it turns out, that's exactly the same as E. It's just written around the different way. Okay, interesting stuff. A sequence of numbers is generated by a recurrence relationship of that form. And again, I've seen questions like this before where they throw people. That's my first term, so it's going to start with 5. And it says, to get to my next number, I'm going to take some constant and get to, my current number. All terms of the sequence have the same value, and the constant is going to be equal to. All right. So That means I've got 5, because my next number's got to be 5, is equal to my constant minus my current value, because they're all going to be 5. This is the terms of the sequence, all have the same value. What do I get now? Well, add 5 to both sides, and I get basically E as my correct answer. All right, again, nice and interesting question, but more about your understanding of recurrent relationships. Question number 19. Edo invests 10,000 in an account earning 3% interest per annum compounding monthly. All right, so 3% interest per annum compounding monthly. He says, turn in the page. What have we got here? Value Vn of Endo's investment after n months is given by. Well, the first thing we've got to do is we've got to turn 3% into a monthly interest rate. So we take 3 and divide it by 12. All right, so if I do that on my calculator, and I'm not going to show my calculator for that, I get 0.25. That's percent. I got to then divide that by 100 to get me to a decimal. So it's 0.0025. All right. It's earning interest, so I've then got to add 1 to that to give me 1.0025. So we're looking for 1.0025 as my rate of interest. And basically, just by sort of process of elimination, it's got to be that one there, right? 1.0025 power of n times 10,000 builds a little bit on the knowledge from the previous question. The effective interest rate for Edo's investment is closest to, right? Okay, so what have we got? We've got 3% compounding monthly. Now, why am I writing that down? Well, firstly, I'm writing it down in a place that the calculator is going to cover it. So let's move that over here, if you will. Bring up my calculator, because there is a great function called menu, finance, interest, effective interest, where if I do EFF and I put the rate of interest and I put comma and the number of compounding periods, then I get 3.04%. And again, that's nice and easy. Notice how just knowing how to use a calculator makes life that little bit more interesting, or at least certainly easier. Sorry if that was covered by my head. I should really have moved that to the top there. All right, so again, just to say that was EFF 3, which is your nominal rate of interest, and the compounding periods, because it was monthly, it was 12, came out to give me 3.04, and that was that answer. Right. Yolandi purchases a motorbike for 30,000. She explores 2 options for predicting the value of the motorcycle after 4 years. For the first 2 years, the value of the motorcycle is depreciated by 10% per annum using flat rate depreciation. For the next 2 years, the value of the motorcycle is depreciated by 10% per annum using reducing balance depreciation. The value of the motorcycle is depreciated using reducing balance depreciation with a constant depreciation rate per annum for 4 years. For both options to predict the same value after 4 years, the rate per annum used for option 2 is closest to. Right, okay, so first things first, 30,000 is going to reduce by 10% per annum flat rate depreciation. So 10% of that is going to give me 3,000. So it's going to go down 3,000 per year. It's doing that for 2 years, so it's going to go down by $6,000. So 30,000 minus 6,000 gives me $24,000. That's after 2 years. Then it's going to depreciate for another 2 years by 10%. So that's going to be 0.9 times 0.9 times 24,000. Now, when I put that into my calculator, I get 19440. And on that, you shall have to trust me. Right, so the value of the motorcycle is depreciated. So now what we're going to do is it's just doing by reducing balance. So we know that V of m is equal to r to the power of n times V0. Well, we know that V0 is 30,000. We're trying to find r. We know that n is going to be 4, and it's going to give me the value of 19440. Now, because I know that r, big R, is 1 minus little r over 100, I'm actually going to rewrite this as 1 minus little r over 100 to the power of 4 times by 3123. Now, again, I'm not going to put that into a calculator because hopefully you should be able to solve that. But when you solve that on your calculator, out comes 10.3%. Okay? Whew, great question. Hopefully my big fat head's not in the way there either. All right, question 22. The recurrent relation below models the value Pn in a financial context after n time periods. There we go. All constants A, R, and D are greater than 1. Four options of what the value of P of N could represent are listed below: a reducing balance loan, an annuity, an asset depreciated using the unit cost method, and a perpetuity. How many of these four options could be represented by? So a reducing balance loan, absolutely, that is one of the suggestions. Yes, because a reducing balance loan basically is something where we have an initial value, we multiply by some sort of interest, and we could take away the value. So I'm going to say yes, that is definitely an option. An annuity. Well, absolutely. An annuity, in exactly the same way, is going to be that I have put in some money, I'm gaining interest, and I'm taking some fixed payment out. So yes, absolutely. An asset depreciated using the unit cost method. If it's a unit cost method, the value here of R is actually 1. All right. So in that situation, the R would be a value of 1. And as it says here that R is greater than 1, then it cannot be an asset depreciated by that. And a perpetuity, absolutely. A perpetuity, once again, just means that I'm putting money into my account, I'm getting some sort of interest, and then I'm withdrawing that interest. So perpetuity, yes. So I'm going to go with D there as my correct answer. All right, question 23, and it's cup of tea time. If you can do me a massive favor and subscribe to my YouTube channel, that would be huge. I literally sit in a room and talk to myself, and the only way I know that anybody watches this stuff is if you subscribe. If you can like this video as well, that will blow me out the water. Apparently YouTube love likes. It sort of highlights my content, and that would be absolutely amazing if you could do that. Nobody watches maths content, so yeah, that would be great. All right, so Todd invests 450,000 in annuity at the start of 2024. Interest rate is 3.75%. So we got this, 15-year, yep. And in which year will the balance of the annuity first fall below 350,000? Huge trick to this question, and I fell for it over and over and over again. So what we can actually do is fire up my calculator. This is actually a bit of it's probably easier done with a financial solver. Now I'm going to say we've got 3.75 in there. My principal value there, I'm going to delete that for the moment. Final value is 0. I know that it's basically going to be 15 times by 12. So what I'm doing here is trying to set up the idea of what would my payment be. My payment would be 3,272 and 50 cents. Okay. Knowing that, I'm going to try and work out how much money is in the account at the start of each year. Okay, and this was the trick to the question. So I know he says, let's delete that. In 2024, I have 450,000. 2025, what I can do now is say, well, okay, how much have I got at the end of the first year? I've got 427,216. In 2026, all I do now is say, well, I've had it in there for 24 months. He says, hitting the wrong button, 24 months, hit there, 403,562. In 2027, 36 months, we've got 379,007, 2028, that's 48. And this was the trick to the question, 353514. Now, if you do 2029, and again, shucks, did I get tricked here? You're going to say 327049, aren't you? You're going to say, oh, well, it's in 2029. No, it isn't. That basically was the trick of the question. The question says, in which year will the balance of the annuity first fall below 350,000? It's going to have to have been in 2028, because by the time it reaches 2029, it'll already have been below 350. It's a trick of the wording, and oh, I got suckered into that one, and I was not impressed in any way, shape, or form. Okay, moving on to question 24. Jared invests 14,000 into an account earning compound interest at a fixed rate per time period. The graph below shows the balance of the account for 4 of the first 5 time periods after the initial investment. The information for time period 3 is not known. Okay, so basically time period 3 is here. Fine. Immediately after the interest was calculated for time period 3, Jared adds an extra one-off amount into the account, and this amount is closest to. Now, I have to say, there are probably other ways of doing this, but I'll be honest with you, I don't know how to do it. It was only by luck I was talking to a friend of mine in Western Australia who teaches this in a very interesting way, and she was like, try it this way, and it worked. I'm talking around corners. If you can do me the honor of subscribing to my YouTube channel, that would be great. Honestly, I sit in here and talk to myself. No one watches maths videos, and subscribing just says, hey dude, I'll watch your video. And if you can like it as well, it means that YouTube will just basically say to other people, hey, this stuff is pretty good. If you can watch it, turn off notifications. If you never want to hear from me again, and most of my friends never want to hear from me again, much less you guys, that would be great. All right. Please don't feel sorry for me. I've got enough of that myself. Right, here we go. I'm going to bring up my calculator. So what I first wanted to do is find out how much money I had in my account at the end of time period 3. How do we do that? Well, I've got to work out my interest rate. I can do that because I know this piece of information here. I've got, right, one time period. And again, it doesn't matter. It's just one time period. Interest rate I'm trying to find. My principal value, I've obviously put in minus 14,000. Payment appears to be 0. Future value is 15,120. Payments per year, compounds per year. And let's change that to the default of end. And you'll probably see where I'm going with this in a moment. And let's work out, whoop. That's the other problem with this calculator. Work out my interest rate of 8%. So I now know my interest rate is 8%. How do we use that now? Well, we now can go to time period number 2 because we now have an initial value there. So let's say we've now got minus 16329.60. And we've got our final value of, we're trying to find, and there we go. If we hit that value there, we get, right, so keep doing that, 17635.968. Now, what it's then saying is we add a payment to here, and then the interest is calculated. Now, if we actually scroll down to your calculator, this PMT at end function, we don't tend to use in Victoria. Okay, fair point. But what this means is, let's make the payment after interest is calculated. But that's not what's happening here. To get from here to here, we're going to add a payment and then add on interest. So what we're going to do is I'm actually say PMT at the beginning, because I'm making the payment at the beginning, then I'm going to have interest added on. Right, and again, if you look at all the financial solver stuff we've ever done before, we add the interest normally and then take away the payment or add on the payment. Now, when I hit enter here, he says, right, because basically I've now got to realize that I'm at number 4. So I've got to put that one in there with a minus. I've started off with, my future value is 19288.80. If I go here to payment, I get minus 224.03, which gives me A as my correct answer. Now, I know that when I sat in the maths office where I currently work, a lot of people are like, no, you didn't need to do that. And to this day, I still don't fully understand how you could do this in any other way. The financial solver makes it so much easier. The idea of payment at end and payment at beginning seemed to make that question much, much easier. And thankfully I'm finished. And hello, welcome to Matrices if you have just joined me. Really good to see you. If you can subscribe to my YouTube channel, it's massive, very important to me. I'm at 11,000 subscribers at the moment. It'd be great if I could get to 15,000. If I did that, I'd have to lie down pretty much. And obviously spread the word. And if you haven't been to mathsguru.com, there is actually a downloadable summary book you can get there for next to nothing. Sorry, I've got to charge. It took me a long time to do. And I'm always updating it. But it's there and it's for you and it's doing anything to make things better for you. Right, use the following information to answer questions 25 and 26. The following life cycle transition diagram shows changes in a female population of mammals with 3 age groups, 1, 2, and 3. On average, what percentage of the female population from group 2 will survive to group 3? Well, group 2 to group 3, that is my survival rate, 0.45, which as a percentage is going to give me the stunning value of 45%. Ka-ching. Nice first question. Leslie Matrices, it's been on the course for a little bit now. Now moving on to question 26. The associated Leslie matrix L for the above transition matrix is, or transition diagram is. Well, if you remember rightly, what do we know about Leslie matrices? Well, our birth rates are along here, and our our birth rates are along there, and our survival rates are diagonal. Sorry, I had to think about that one for a moment. We can't have 0, 0, 0. So looking at that one, no, it can't be that one. Okay, that sort of looks in the right format. But no, that suggests that children can have children, and that would be a horrible idea. So that's not it either. Keep scrolling. Nope, these values here certainly don't go in a column, so that's no good. They certainly don't go in a row, and so actually E would be my correct answer, where we have the values of my birth rates going along there and my survival rates going along there. Now, moving on to question 27. Matrix V is an n by n matrix, which means it's square with a determinant equal to 1. Okay, so that means AD minus BC is equal to 1. The product of V times V to the minus 1 will result in... Now, basically, the way I did this was actually through creating a matrix. And I created one with 2 and 3. Now, I know that the determinant had to be 1, so it means the opposite corners had to subtract to give 1. So that's 6, and I made that 1 times 5. So let's call that matrix V. If I now multiply that by its inverse as 2, 5, 1, 3 to the minus 1, if I throw out my calculator because I just did this a moment ago, so 2, 5, 1, 3 times 2, 5, 1, 3 to the minus 1 gives me, oh yes, an identity matrix. So again, there may be other ways of doing this, but I was like, well, I can create that. Life is good. Matrix D is a 2 by 2 matrix where each element is given by Dij. Which rule will result in a binary matrix? Now, binary matrix has just ones and zeros in it. And again, there are lots and lots of ways of doing this, but I tend to go to menu, and unfortunately, the Casio ClassPad, I don't think you guys have this. So matrix, create, and we got this great function in the TI Inspire called construct map. Now, what you do is you put in the formula I plus j, and we tend to do this through trial and error, but once you've done the first one, it's really easy. 2, 2. He says 2.2. So the format of this is construct mat. He says, writing terribly, formula, comma, the letters you're using for the formula, and the order of the matrix, or how big you want the matrix. So here I would do I plus j as my formula. I've got to tell the calculator the rows is I and the columns is j, all right, otherwise it doesn't know, and that I wanted a 2 by 2 matrix as a result. If I hit enter, he says bring it up, and that sounds weird, bring it up. What I've got here, 2, 3, 3, 4. So it's definitely not A, because that's not a binary matrix. Now again, all I need to do now is do this and change this to I minus j. And I can't think of another way. A binary matrix, no, because it's got a -1 in it. So a binary matrix isn't that. Hit that again. So what have we got now? I times j. I times j, he says. Yep. Nope, that's not either. So cross that through. Where are we now? Copy that down. And let's change that to... is that divided by j? God, my eyesight's horrible. I divided by j. Hit enter. Nope. And then so hopefully, and again, I wouldn't just chance this. I would still work it out and make sure that it's right. Because you never know. It may well be that the calculator function's wrong, but it's I minus j squared, he says. And there we go. We have my binary matrix. And a binary matrix is just a matrix made up of ones and zeros. So E is my correct answer. Turn off the calculator. What do we got here? Matrix J is a row matrix of order 1 by n. K is a column matrix n by 1. Matrix J, T is the transpose of matrix J. And matrix KT is a transpose of matrix K. Consider the following matrix products where n is a whole number greater than or equal to 2. Okay. How many of the above matrix products are defined? J squared. So that's going to be a 1 by m. Multiplied by a 1 by n. That's definitely not going to be defined, he says, so that's a no. What about j times k? That's going to be a 1 times n, and k is the transpose of k, which is going to be a 1 by n. Try that one again. Read the question. J is a 1 by n, and k is an n by 1. Yep, that is definitely going to work, he says. So let's do a tick there. K times j. So k is an n by 1 times k is a 1 by n. Yep, they're going to be middle. Yep. So the transpose of j is going to be n by 1 because the rows and columns are just going to change when you got a transpose. Times by the transpose of k, which is a 1 by n. Yep, that's going to work. And the transpose of k, which is a 1 by n, times by the transpose of j, which is an n by 1, and that is going to be right. So in which case, I think D is going to be my correct answer. Matrix R is a column matrix. You've got T-A-L-L-Y. A permutation P is multiplied by matrix R to form the matrix product Q equals PR. Okay, if Q is equal to R, how many different permutations could have been used? All right, so if Q is equal to R, So what have we got here? So Q is going to be TALLY is equal to P, some permutation matrix, times by TALLY. Well, in which case, what do we got here? So how many permutation matrices could it be used? One. Excuse me. Well, really, no. It's the point of it is here, we've got to keep all the letters the same. So one permutation matrix would keep all the letters the same. So one would keep all of them the same. The second permutation matrix would be basically effectively swapping those two L's over. And I don't think there's anything else because you can't really permute that in any other way. So for B, the answer is going to have to be 2. A group of meerkats lives in a zoo enclosure. This is so similar to a question I have seen before about aeroplanes staying in Melbourne and Sydney airport. And if you haven't seen that one, it's a great question. A group of meerkats lives in an enclosure at a zoo. The meerkats sleep during the night in one of two chambers, chamber A or chamber B. The transition diagram below shows the proportion of meerkats that stay in the same sleeping location or change sleeping location from night to night. Every night there are A, meerkats in chamber B and B in chamber B. Now the trick to this question, and it's exactly the same as the sort of one that we've had previously, is that means that there are the same number of meerkats staying in A and B, which means there are the same number transferring between each of those there, right? Of the meerkats sleeping in chamber A on Friday night, 8 slept in chamber B the previous night. So it means that 8 had transferred that way. B, that means that 0.2 of the number who were at B is equal to 8. So I can put into my calculator effectively 0.2 divided by 8, and that gives me, 20% of a number. It's Muppet, 8 divided by 0.2, that's basic primary maths, is 40. That means that 40 were at B. Now, if 8 went this way and the same number stay every single night, then 8 must go that way as well. So that means that 40% of those at A are equal to 8. So if I do 8 divided by 0.4, I get 20. And so in which case, the total number of meerkats are 20 plus 40, 60. E is my correct answer. Love, 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 love. Question 32. An online shop offers monthly subscriptions for protein powder. The shop offers protein powder in 3 flavors: vanilla, chocolate, and malt. Let Pn be the state matrix that shows the expected number of subscribers for each flavor n months after sales of the protein powder began. The expected number of subscribers for each flavor can be determined by the matrix recurrence now. Where? The state matrix P2 shows the expected number of subscribers for each flavor's 2 months after sales began. The increase in the expected number of subscribers for vanilla between the initial spells P0 and the first month after sales began, P1, is equal to, right. Well, the first thing we can do is we can basically backtrack this to try and work out, and that's ultimately what we've got to do. We've got to try and reverse this. So we know that P2 is equal to, and I'm going to get this from my formula above. Let's do this up here, actually. P2 is equal to my transition matrix times P1 plus my value of K. Can I work out what my value of P1 is? Absolutely, because I can put it into my calculator, or I can work out that P2 minus K is equal to T times P1, or T to the minus 1 of P2 minus K is equal to P1. So firing up my calculator. Yep. So firing up my calculator. Sorry, I was just thinking there for a moment. What have we got here? So we're going to put in my transition matrix. It's a 3 by 3, thankfully, 0.2. Oops, sorry, my thing was on my calculator. 0.2, 0.1, 0.4, 0.2, 0.1, 0.4, 0.6, and 0.8. Raise that to the power of -1. We're going to multiply that by, if you will, my, what does it say? P2 value. So you've got to put in a set of brackets. Let's do this. So number of rows is 3 by 1. And we want P2, which is 147, 137, and 199. And from that, we want to subtract my value of K. So no, another one of those, 3 by 1, hit enter. And that gives me 93, 59, and 9. Hit enter, and there we go. So that's my value of P2, which should be 120, 98, and 104. Sorry, that's my value of P1. And we can repeat the same process by basically doing the same thing to get my value of P0. Now I'm just going to go up and copy that down. And rather than have this value here, which is my P2, I'm just going to copy that into there and then hit enter. And that's going to give me 60, 49, and 52. All right, so what does the question actually ask? The increase in the expected number of subscribers for vanilla between the initial, let's turn this off for a moment, between the initial sales P0 and the first month. Well, which one is vanilla? Vanilla is the top one, so that's that one, and that one, and that one. So we want to go from P0 to P1, from 60 to 120, would therefore give me, I'm just checking my answers, 60 as my correct answer. Now, weirdly, there may be another way of doing that, but I can't think of what it is off the top of my head, but I think that's effectively going to be it. And then we're on to networks and decision mathematics, the last section of this particular video. Paper 2 is going to be recorded very, very soon. It's probably already live by the time you're watching this, but if you can subscribe to my YouTube channel, that would mean the world to me. Again, nobody watches maths videos. Yeah, everyone tells me, do you know what, Maths Guru? You're the GOAT, which is weird because my name's Darren. But anyway, you're the GOAT. You're amazing. Your video's really, really good. Yeah, I can't get people out there to find them. So if you can spread the word to your teachers, what have you, that would be great. How needy do I sound? Very, very needy. Right, question 33. On the graph shown above, the number of vertices of even degree. Well, we love this one, so it's got degree 3 because there's 3 lines coming off it. Degree 2, 2 lines coming off it. Degree 2. This one was the trick. It was 1, and that one's got 2. So 1, 2, 3. We've got 3. So D is going to be my correct answer. Question 34, that was a waste of paper. The adjacency matrix below represents row connections between 4 towns labeled L, M, N, and O. The graph that represents all the row connections in the adjacency matrix is right. So the first thing is we've got a loop at L. So I'm going to try and find anything that doesn't have a loop at L. There we go. E doesn't have a loop at L. So that's no good to me. I'm going to look for 2. So 2 connections between M and O. So that's got 2 connections between M and O. We got 1 there and 1 there. This has got 1, 2 connections. Yep, so that's okay. That's got a connection. That's got a connection. Still okay. M and O, yep. Okay, so that hasn't actually discounted any. Just want to make sure that I don't have... Oh, no. That's only got 1 connection to M and O. So actually A now is defunct. Goodbye A. My apologies to anyone out there who was shouting at the screen going, no, you loser, you've got it wrong. Okay. Jill. Right, what do we got here? So 1 connection between N and M. 1 connection between N and M. So what do we got here? So M and N, we've got 1 there. We've got another 1 there. So it's definitely not that one. 1 connection between M and N, yes. 1 connection between yes. So what have we got? 1 connection between L and N. So we've got 1 connection between N and L. So 1 connection between N and L, yep. Oh, there's no connections between N and L, so it's basically not that one. So C is my correct answer. So just trial and error. I can't see how there's another way of doing this one here. Okay, the vertices of the graph below represent cabins in a holiday park and water pump P that will supply them. The number on the edges show the lengths in meters of water pipe required to connect the cabins and the pump. The water pipes will cost $52 per meter. What is the minimum cost to link all the cabins to the water pump? Right, okay, so this is a minimum spanning tree question. Now, again, it's interesting because the general maths textbook in year 11 has an algorithm called Cross-School's algorithm. And yet it hasn't made it to the year 12 book, which is a little bit weird because it makes a lot more sense than Prim's and much, much easier to do. Now, I'm going to give you a crash course in Cross-School's algorithm, but only if you hit subscribe. No, I'm not going any further. And, well, actually, I can't. It's a video. You can just ignore me. But if you can hit subscribe, that would be great. Now, Cross-School's algorithm basically states this. Much like Prim's algorithm, you can't have circuits. You can't close things off. But you basically highlight from the lowest numbers. So basically, the first thing I'm going to do is look around here for my lowest number. It's 7. So I'm going to connect that. My next would be 8. So anything that's got an 8, I'm going to highlight. Have I created any circuits at the moment? No. So I can keep going. 8. Where's my next one? 9. So I've got a 9 there and a 9 there. And believe it or not, this is amazing. I just keep doing the 9s. There's a 10. But I can't use the 10 because it would create a loop. So 10's no good to me. That 10's no good to me. I keep going. 11. Well, I can color in that 11. That works. And I'm almost there. How am I almost there? Because I've almost connected all of my points together. All I got to do is go 12. And believe it or not, that is it. That is my minimum standing tree. So much easier than flipping Prim's algorithm. And I said flipping. But anyway, so what do we do now? Well, it wants the cost to link all the cabra in. So we'll do 12 plus 9 plus 8 plus 11 plus 9 plus 8 plus 9 plus 7. 12, 9, 8, 11, 9. So when I add all those together, I get 73. And I'm going to times that by 52 on my calculator, but I'm not actually going to do that. And out comes my correct answer of B. Crosscall's algorithm. Right, 4 students, Peggy, Quincy, Radley, Sarah, are grouped together to complete a project. The project is in 4 parts. Label W, X, Y, and Z. Each student must complete one part of the project. The table below shows each student's estimate of the score they will receive if they complete each section. Based on the estimates, which of the allocations will maximize the students? Now, obviously, when I looked at this, I went, oh, thank God for that. It's not Hungarian algorithm. But even if it was Hungarian algorithm, if you have the TI Inspire, there is a software package you can actually put onto your calculator that is the Hungarian algorithm, and it does it all for you. And weirdly, there is a way of doing the maximum using the Hungarian algorithm. But this question, to believe it or not, is much, much easier by just doing it by trial and error. It's probably quicker as well because, one, we don't formally teach you anything to maximize. But they've given you 5 here that you can try and say, well, okay, we can actually work out, because I know that Quincy, yep, was 19. All right, so Quincy got 19, Sarah got 16, and you're going to turn around and say, where am I getting it from? Quincy got 19, right? Sarah got 16, Radley gets 17, and Peggy gets 19. Then if I do that and add those together, I get 71. And when I do the same here, I get 18, 16, 16, and 18. That gives me 68. Here, 16, 15, 10, and 18, which gives me 59. Here I've got 18, 16, 15, oops, he says writing 17, and 19, which gives me 68. And this one here gives me 16, 16, 17, and 20, which gives me 69. And so my maximum will be A. And yes, it's time consuming. Some of these questions are meant to be time consuming. VCAA make no apology for that. It's just the case of the way it goes. Euler's formula can be applied to which of the following graphs? Now, Euler's formula can only be applied when it is planar. And for it to be planar, it's got to have no crosses whatsoever. All right, so we basically got to try and work out which ones of these graphs can be drawn planar. All right. Now, as it turns out, while I can, and this is really, really hard, okay? It really frustrates me that I can't do this. But if I try and draw a straight line through there, he says, so that that disappears. All right. Actually, let's just make that pen thicker. And I try and do this one here. Now, really what I'm trying to say is I'm now going to draw that line here. And I'm going to draw this line all the way out here. I still have a cross, and I can't undo that crossing point. So basically, that one there is not planar. Can we do the same with others? Well, this line here can theoretically now go... Actually, keep that one in, he says, because that's what tricked me the last time. So this one here, between those 2 points, can be drawn outside here. And this one here can be drawn, so many choices, outside here. And we now realize we've got no crossings. So in which case that can be. Let's go to the next one. Let's delete this one here and move it outside because we can do that. And then let's delete this one here. And let's move this one outside there. Are any crossing at this moment in time? No, so that can be done. And that can obviously be done. So if I am right, the correct answer for this question is basically E, graphs 2, 3, and 4 only. And again, made much, much easier by the fact I had a white pen. And this question I hated. I have to say, when I did this, it took me 3 attempts. But anyway, it was more because my algorithm was all over the place. Now, if you understand what I'm talking about and have watched my previous video, there's an algorithm. But you've got to choose the route through here. It's not necessarily sequential, and there is a way of working out whether you are right. I'm going to work through what actually works, and hopefully you'll understand. If you don't, there are videos on Maths Guru, and if you can subscribe to my YouTube channel, that would be massive, and like this video would be huge. Thank you very much. Right, okay, so the following directed network or graph represents the one-way path between attractions at a historical site. The entrance, exit, and attractions are represented by vertices. The numbers on the edges represent the maximum number of visitors allowed along each path per hour. What is the maximum number of visitors? Rightio, so the first thing I'm going to do is I'm going to work through this path here. All right, seems as logical as any, and I can get 13 people through there. So that's 0, 21, knock 13 off there, it gives me 43. Okay. Next thing I'm going to do is I'm going to pass through this way. Again, it seems logical. Maximum I can get through there is 16. So I'm going to write down 16. That's going to become 2, 0, 16 off of there gives me 27. Right, next one seems to be logically 9. Because I can't get anyone up here anymore. I can't get anyone along there, so it makes sense to try and work out how to get through there. My maximum flow through there is going to be 9, so I'm going to write down 9. So that leaves me 22. That is now 0. 9 off of there is 18. Right, where can I go next? Well, it seems sensible now maybe to get some people through here, 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 and here if I can. 15 seems to be my maximum there, so it's 15. 15 off of there is going to give me 7. 15 off there is that. 15 off there is 2. 15 off there is 3. Right, where next? Okay, no, we've still got some here, 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 and here that I can get through. So that would be 7. So there's 7. So 7 off there gives me a 0. 7 off of there gives me 13. 7 off of there gives me 25. And 7 off of there gives me 14. Can I get anything else through? Yep, I can still get stuff through because I can't get anything through there anymore or there. So my only path seems to be here. I've got 18, 25, and 14. So let's do 14. So 14 off there gives me 4. 14 off there gives me 11. 14 off there gives me 0. Can I squeeze any more through? It does happen that I can. I've got a 4, 11, a 2, and a 3. So I can squeeze 2 through there. So that's going to give me, what's that, 2, 9, 0, and 1. And I'm fairly sure I can't get anything through there. Now, the test of this is, and I'm going to add all that up, and hopefully this gives you 9, 18, 19, 20, 31, 36, 3, 4, 5, 6, 7, 76. So we'll come back to that in a moment. The way to be able to do this is, can you now cut through zeros or pass it or go backwards through in such a way as you can get it to cut properly at 76? And the way to do that actually is this way. You go through there, you go through here, through there, through there, and through there. All right, so basically, if we were to rub all these values out, which we won't, 13, 16, 17, and 21, I think are the ones that add together to give me the right values. 13 and 16 is 39, 49, 56, I think, hold on, 13 and 16 is 29, 39, 46, 56, 66, 67, and that 9 there makes the 76. All right, now people go, but what about the others? Don't they cross through? And my advice to you is actually to color in. So what I've now started doing is teaching my lads to basically shade the side of the dotted line that the source is on, and this is my source. So what we notice is that line is going from colored to uncolored. This one's going from uncolored to colored, so that doesn't count. Colored to uncolored, which is good. Colored to uncolored, which is good. Colored to uncolored, which is good. And colored to uncolored, which is good as well. And again, I'm going to redo my video on this. But to answer this actual question, what you get then is an answer of 76, which gives B. Time consuming much? Yes. Moves on to question 39. A group of students set out from the exit or entrance and walk to the exit. The students will walk together and travel along the same route. They are the only people visiting the site that hour. What is the maximum number of students that can be in the group? There is only one way of doing this, and it's trial and error. So what I started off by doing was saying, well, can I get 31 people through this network? And I am loath to rub this off because I'm actually going to reuse all of this. So what I'm going to do is I'm going to cut that at this moment in time, and I'm going to go, right, can I get 31 people through here all in one go? Well, yes, I can get 31 there, but nope, they can't go that way. Nope, they can't go that way. So 31 isn't a valid answer. 31 can't go that way either. So 31 is not basically possible. So cross that through. Let's look at 20. Can I get 20 people all in one go through? Well, I can get nope, nope, and nope. So yes, I can get the 20 people that way. No, I can't get them that up here. I can't get them down here, but I can now get them down here. Can I get those 20 people? Now I've gone here and here. Can I get 20 people along here? Yes. Can I get 20 people on there? Yes. And so basically the answer, really by inspection or trial and error, is 20. Final question of this video. A project has 10 activities labeled A to J. The table below shows the immediate predecessors for each activity, and each activity has a duration of at least 1 day. They give you 5 options about the project, which isn't true. We'll come back to those options in a moment, because to be honest with you, we're going to have to draw this. And again, when I did this initially, I was like, why can I not draw this properly? But when you sit down and have a go at it, first thing we know is that A and B come off the start. So there is A and there is B. C comes off of A. So I'm going to do C that way. B comes off of D. And E comes off of B. So I'm going to do D and E. Now G comes off of D and E. Well, if that's the case, there has to be 2 dummies connecting there to G, wherever G is going to end up going, all right? Right, so H comes off of C and F. All right, sorry. F comes off of D. All right, well, we didn't do F comes off of D, so I'm going to do F comes off of D there. F comes off of D. G comes off of D, V, yep. H comes off of C and F. All right, well, okay then. I can now join those together, and let's get H coming off of there. I comes off of E. Okay, so I comes off of E. And G and H comes off of J. So hold on a moment. H comes off of C and F. Yep. E comes off of I. Yep. J comes off of G and H. So in which case, I'm now going to connect. Oops. What was that? H comes. Oh, nope. What comes off of E? B. Nope. D and E. G. So G comes off of there. J comes off of there, and I cannot be left hanging, so it has to come there. So there we go. That's my activity network, and I'll be honest with you, had to get help with that one. That's some maths guru I am. But now let's look at this and see whether we can answer the questions. Okay, so now having drawn this, let's have a look at the options and try and work out which one is not true. Okay, the earliest start time of activity H could be 2 days. The earliest start time of activity H could be 2 days. 1, 2, it could be 2 days, but that would be 1, 2, 3. All right, so the earliest start time could be 3. So actually A is my preferred answer at the moment. Let's see. Not true. In the network for this project, there will be a dummy activity from the end of D. Well, that is true, so that can't be right. One of the paths through the network is BDGJ. BDGJ. Yep, that is true. The latest start time of activity A could be 3 days. All right, the network for this project would require 2 dummies. Well, that's definitely true. So the latest start time of activity E could be 3 days. Well, if we assume that all of them are 1, and that's going to be 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Let's assume they're all 1. So basically, I've got this here is going to be 0, 0. Let's just put my boxes in for a second. Try and do this really quickly as my dummy. Dummy. Who you calling dummy? Really old joke, but anyway. Now, you notice I don't do these on the nodes. We just did a sack with my group and didn't go well with people who tried to do it on the nodes and not listen to what I told them. But anyway, 0, 0. So that's going to be 1, 1. That's going to be 1. So to get here is going to be 2. And that's going to be 2. And what's that going to be? 1 plus 1 is going to be 2. Right, so here that's going to be a choice of 2 plus 1, 1, 2, 3. So that's got to be 3. That's going to be 2 coming into there. 2 plus 1 is 3. Yep, 3. 3 plus 1 gives me 4. So, sorry, that's going to be 3 plus 1 is 4. 4 plus 1 gives me 5. All right, and G is going to be 2. 2 plus 1 gives me 3. Yep. All right, okay. So then backtrack this. What am I trying to find? The latest start time activity could be 3 days. 5 minus... Oh, we didn't do that one. So what is that? That's 2. So that must be 2. 2 plus 1 gives me 3. 5 minus 1 gives me 4. And we've got 5 minus 1 gives me 4. 4 comes into there. 4 minus 1 gives me 3. 4 minus 1 gives me 3. That's going to give me 3. That's going to be 3 in there. And that's going to be 3 there. Yep, so the latest start time for activity E could indeed be 3. So nope, in which case, hey, that was a lot of faffing work, if I'm being brutally honest there. But again, the trick to this question was basically getting that answer there. Right, hopefully this has made sense. I'm done. All right. Thank you very much for watching. If you can do me the massive favor, please, of subscribing to my YouTube channel, that would be great. And liking the video and letting people know out there that this resource is there. I'm going to record paper 2 fairly soon. That will be up on YouTube or maffsguru.com fairly soon, if it's not already up. Take care of yourself. If you're about to sit your VCE exams, wishing you the biggest best of luck. Until next time, take care. Bye-bye.